Okay, so for the first article that I read Never Say Anything a Kid Can Say by Stephen Reinhardt. And there were three key points that I noticed while reading this article. And the first one was that he changed how he taught to go from being a lecturer to a listener. And I thought that was really cool. Like there was a quote in here talking about how lecturing is just a transfer of information from the notes of the lecturer to the notes of the student without passing through the minds of either. And so he, instead of making it where all the students have to listen to him, he sits there and he asks questions and models his lessons to make sure that the students are the ones who are talking and kind of leading themselves while they're learning with the teacher. And then the second key point that I noticed was that he put a greater emphasis on questioning, and not just questioning that is simply answer this or yes or no questions. He asked questions that required deeper, higher level thinking. And I thought that was really awesome because it required the students to think. And instead of whenever they would ask the teacher, is this right, when they would find an answer, instead he would still ask questions to keep the learning going. So instead of just having that basic level of learning that most students get while they're learning mathematics, they go into a deeper level so that they have a better understanding. So it's not as much content per se or like problems. It's more, it's problems that are deeper, required thinking. And then the third point that I found was to use your teaching to hold students accountable for their thinking and learning. And I think the best example that he gave was the think, pair, share tip in the article, because he would give a problem, have the students think about it individually, pair it together to compare and work on it together, and then share it as a class. And I think that's great because it doesn't leave one student doing all the work and the other kids just sitting back and letting the other person do it. So everybody's responsible for their learning in this type of learning environment. And I like that as well. And this article was very eye-opening for me because I was able to learn some tips that I can apply to my classroom. And instead of just teaching, and hoping that they're absorbing the material, I can work on the questions that I ask, the way that I ask them, and kind of pulling the information to see, are they learning the material? Are they retaining it? And all of that stuff. So I will put a greater emphasis on questioning through using the tips in this article. For the next article I read, it's called Shape Up. I found this on the internet when I was looking for articles that deal with early elementary grades and shapes, because that's the standard that we are going to be teaching for the field experience in this class. And some, like, the key points in this are making sure that you are using the proper terminology when describing shapes. So what they see a lot of times in classes is, especially with like 2-dimensional and 3-dimensional objects, they'll see a sphere, and before they introduce the terminology for that 3-dimensional object, they'll let the students call it a circle, or they'll see a cube and they'll call that a square. And what this article does is try to provide us with information to make sure that there aren't these broad misconceptions with shapes because of the improper terminology that we use. It says to emphasize the properties and characteristics of a concept. So when you're talking about a square and a rectangle, a lot of times students, they'll see a rectangle and be like, oh, that's a rectangle because it has longer sides on one end and then shorter sides on the other. And then with a square, it's the same sides all around. But then when they get into middle and high school and they're comparing properties of geometric or quadrilaterals, they learn, oh, a square is technically a rectangle. And so so what they're trying to do is make sure that we are kind of introducing terminology and concepts early on, so that they're not thrown back in older grades. And then they say to provide many examples and non-examples, even if they're not ready to learn about that specific shape. And I think that's a really good idea, because if they're learning about triangles, they need to see all different types of triangles, not just the regular equilateral ones, because they will think that only an equilateral triangle is the right kind of triangle, and when they see a different one, they think it's wrong. And then they say to challenge the understanding and broaden their generalization so that there isn't any confusion in older grades. So basically, this whole article is making sure that when we are teaching geometry in the early grades, like preschool, kindergarten, first grade, we are introducing terminology so that they know that there are different aspects to shapes than just the primary ones, so that there isn't confusion in the older grades. And for my reflection on this article, I found myself thinking that, like, because of the things that I was told, like, oh, a sphere is like a circle, before I learned about 3D geometric solids, I thought that a circle was a sphere. And so I think it's a great idea to make sure that students um, learn this stuff before it confuses them. And I'll make sure to do that in my classroom as well. For my third article, I did unpacking word problems for diverse learners, and I really liked this because it talked about introducing schemas to do addition and subtraction problems. And the different schemas are combine, compare, and change. And what the teacher is supposed to do is first off introduce the schemas. And teach the students about that so that the students get a good knowledge of that, of what the schemas are. And then they teach using the schemas and the visual aids to solve the word problem. So one of the examples that they gave was, Maria had some cupcakes, then she baked 7 more cupcakes. Now she has 10. How many cupcakes did Maria have to start? And so what they do is they use the information that they get to figure out, okay, is this a compare, a change, or a combine question? And then they use the graphic organizers like this to figure out the word problems. So the students have the ability to read the problem, interpret the problem, figure out what information they need to solve the problem, and then check it. And something that I really liked about this, like as my reflection, I loved the step-by-step process, because especially me being a visual learner, having those diagrams to kind of fill in, okay, this is the information that I know and this is the information that I need, it would have been very helpful for me. And so when I'm in my classroom and I'm teaching these beginning word problems in early grades, I will do my best to use these schemas to help the students figure out how to best solve the problem. For the next article, I read 13 Rules That Expire, and I really enjoyed reading this article because what they did, their key point when they began was showing us that there are a lot of rules that students are taught when they are in elementary grades that often, well, that do expire when they get into older grades. And that can cause a lot of frustration in students because they sit there and think that math is this subject that is always going to change and it's always going to be tricky and a mystery. And then their second key point was identifying the rules that expire and kind of explaining, okay, this is the rule that most teachers teach, but this is where it actually expires. And I like how it gives the grade and the standard that shows that, yes, this rule does expire. And then the last key point of the article was putting an emphasis on changing the terminology, or like the language that we use while we're teaching, because the language that we use is what the students will use. And instead of us just teaching them things to make math easier, what we need to be doing is teaching math so that they have a greater understanding of mathematical concepts instead of just having a way to just plug and chug and get the answer, you know. And for my reflection on this article, I really related to these rules, I guess, because these are all rules that I had to deal with learning that, oh, these actually aren't rules that stay the same forever. Because, especially with the 10 times a number, you just add a zero at the end, I had to reteach myself or be retaught that concept when it came to decimals. And so when I'm a teacher, I know that I will keep this article with me and make sure that I'm not using any, like, making sure that I use language that lets them know, like, this is how it is for this particular lesson, but this rule won't always be the same when you get into older grades. For my last article, I read 10 practical tips for making fractions come alive and make sense. And the first key point that the article makes is that a lot of times fractions are very hard for teachers to teach and for students to learn because it has there are many components to it. And then the next key point that they make in the article is to give those 10 tips to help teachers better communicate what fractions are and how to understand them better. One of the things that I liked the most was tip number 5: provide a variety of models to represent fractions. And I think that's great because a lot of these manipulatives, they're hands-on, they're visual, and so that helps a lot of students. And then the last thing that they do is they give us some sample activities to do with the students to kind of help better broaden their knowledge of fractions. And for my reflection, I really liked this. I never really had a big issue with fractions, but I know friends that did. And so I will make sure that when I'm teaching these fractions that I'll be using the tips and like seeing how, like, kind of doing the one-on-one interview process that they were doing with the students to see their thinking and how they make sense of fractions. Because when I know how the students are thinking about fractions, then I'll know how to better teach and communicate how to how for them to know the concept of fractions better. Overall, I'm very glad that I had the opportunity to read these articles for this project because it gave me a lot of insight onto how I need to kind of change my perceptions of teaching math in the classroom today. Um, One of the biggest things that I learned was that questioning is very important because you can ask questions that get to the surface level, or you can ask questions that get to deeper thinking. And through the never say what a kid can say and then the word problems, I think by using the questioning ideas in those two articles, I'll be able to um, help my students learn at a deeper level. And then the second thing that I grabbed from these articles was that proper terminology when teaching is so important because it talks about all the misconceptions um, that can be learned through using wrong geometric terminology in the shape up article, talking about how using wrong terminology when telling about the rules in math, that they sometimes change, and that can be really confusing for students too. So I will make sure to always make sure that I am using the proper words, terminology, concepts when I'm teaching a lesson in math because I know math is confusing as it is, and I don't want to confuse my students even more. And then the last thing was making sure that I have lessons that help deepen the meaning, the understanding of the material as well. So, like in the fraction article where they mention different activities that they can do, and then in the word problem article, and also in the shape up article, gives a lot of cool activities to help strengthen their knowledge on the math content that I'm teaching.